Hello everyone and welcome back to my YouTube channel. So from this video we are going to talk about the VectorDB operations with the Chroma DB. So previously we had a similar video which discussed the VectorDB operations with the files vector database. So after that I got some requests to discuss the VectorDB operations with the Chroma DB. So from this video, we are going to discuss about how to initiate the VectorDB, how to we can have it persistently in our disk, as well as how can we use it in memory, and then the collection operations, create, get, read, modify, and delete collections, and how can we add documents to the collections as the raw documents as well as the files, and view, update documents in these collections, and do the similarity search, metadata filtering, and finally, we will talk about how can we use Chroma DB for the retrieval augmented generation. All right, so without much talking, let's move to the tutorial. So before moving to the tutorial, I will invite you to subscribe my channel and share this video with your friends. All right, let's go through the tutorial. So in the left hand side, you can see the table of contents. So these are the steps that we are going to go through. So the first step is to install the required libraries. So we will be installing the Chroma DB and then the LangChain libraries and the PyPDF library to pass our documents. So next we can import these libraries. So we are importing the Chroma DB libraries in order to do various operations, and of course we are using the LangChain. So this part basically we need to use when we are doing the document passing, as well as at the end we are doing some RAG examples. For that we need the LangChain. And also I am using some additional supported libraries in order to data visualization and datetime kind of stuff. All right, so and also we need to set our OpenAI API key. So we will be using OpenAI as well as some open source libraries, LLMs, for the embedding construction and the language generation tasks. So that's how we can import the libraries. And also I am using the secrets from the Google Colab. So here I am using the secret value. So you can also set these values in your notebooks. All right. So that's import libraries. And next, let's go to the creating a Chroma DB client. In order to work with the Chroma DB, of course, we need a Chroma DB client. So this is the connectivity between the Chroma DB and all your documents, how you can talk to it and get all your data. You have to create this Chroma DB client. So there are two ways we can implement the Chroma DB client. The first one is non-persistent manner. With this code, we can simply create a Chroma DB client. So this one actually will use the memory or the RAM. So it will be flushed after your runtime is closed. All right. So the other way is to use it in the persistent manner, where you are using your disk, or if you're using Collab, you are simply storing your vector store in your Google Drive. So this is the recommended way, because uh, if you do this, your Chroma DB, all these SQL and the Parquet files will be stored in your Google Drive or in even in your computer, so that the next time you can use it. So if you want to reuse your vector databases to query, definitely you should use it in persistent manner. So in memory and in disk usage is these two. So in this tutorial I am using a persistent client where I am storing all my vector DB files in my Google Drive in this particular location. So when you are using this, you can simply change this location and provide your own location. So if I show you that location, something like this. So I have this vector store folder, to store all my VectorDB files. And also I have this data file. This folder contains some two PDF files. I will be using these when I'm doing the indexing. So that's it, and this is the notebook. All right. All right. So now we discussed about how can we create a Chroma DB client that will expose all the functionalities. Next, let's talk about how can we create collections in Chroma DB. So collections is a good concept we have in Chroma DB where we can create groups of documents in the vector database. So in the other VectorDB implementations also we have this concept, but generally in VectorDB we have all the documents in a general space. But with ChromaDB we can create the collections. So these collections will be will separate your documents from each other. So it's like one ChromaDB instance can have many collections. Each of these collections contain different documents. So especially in ensemble retrieval kind of implementation, this is really important. For example, when you have documents which are not related to each other, having them in different collections is a very good idea to separate them, because when we are doing the retrieval augmented generation, we can point out to the relevant data scopes. So in order to create the collections, we need to define one more thing, that is the embedding functions. You already know what is embedding. So when we are creating the vector DBs, we should also define the ways we are converting these document chunks into numbers. So that's what embedding function stands for. So here we can simply create the embedding functions in this way. So here I'm creating the OpenAI embedding function. From the embedding functions from the Chroma, we can import the OpenAI embedding function. Then we can provide the key and then the model name. Similarly, we can use free and open source embedding functions. So here I'm using the sentence transformers with all mini LM L6v2. So in the collection creation, we need to forward these embedding functions. That's how it convert all these documents into the vector space. Okay. So after creating the embedding functions, we can create the collections. So in order to create a collection, we can follow this syntax. So we have created the Chroma client. So the Chroma client dot create collection syntax. Then we can provide the name of the collection. So this is simply a group of documents. And then we can set our embedding function. And then we can also provide some of the metadata. So description, and also I'm providing the date time when this collection is constructed. Then again, I'm creating another collection, the collection 1 and the collection 2. So in this collection 2, let's use the embedding function. So here I'm using the sentence transformers embedding function, which is free and open source. So for the second one, I will be using this open source embedding function. Okay, so I will set the embedding function. All right. All right, so now we have created these two collections in our Chroma DB, the My Collection 1 and the My Collection 2. So the first collection, we have the embedding function sentence transformers. The second one, we have the OpenAI embedding function. So all the documents that we are pushing to the collection 1 will use the sentence transformers embedding function, and the second one will use the OpenAI embeddings. Okay, so now we have created two collections, and next let's go through some of the collection operations. So first of all, from a given Chroma DB, we can list all the collections available from the Chroma client.list collections operation. And also, if we need to get some specific collection, we can always provide its name and then use the get collection command. And also we can delete a collection from the Chroma DB we can simply use the chroma client.delete collection, and after we can provide the name of this collection. And also the peek command, we after getting some kind of a collection from our Chroma DB, we can use this peek command to see what we have inside, basically the documents we have in these collections. And collection.count will also provide a number of documents you have in these collections. And also, if you need to rename your collection, again, you can use collection.modify, and within brackets, you can provide a new name. All right, so these are some of the operations that you can use to update or modify, delete, or change your collections in Chroma DB. All right, so if we run this like this, it will provide information. So we have two collections, my collection 1 and my collection 2. And if we peek into the collection 1, we currently do not have anything. So you can see everything is empty. And if we count all the documents in the collection 1, again, we do not have anything. We just initiated these collections. We do not have any documents currently. All right, so that's how we can create a collection. And also we discussed about some of the operations that we can do with these collections. All right, so next let's talk about how can we add the documents to our collections. So adding documents, we can do it in two ways. The first one is the direct method, where we can just simply call after getting the collection. You can get the collection from this command if you are adding data to existing collection from the persistent data. Or otherwise, if you are defining collection, you will be anyways having this collection variable in your memory. So in order to add a data or the documents to the collection, you can simply run this command. If you have all these document text already extracted, so the documents is a list, and you can provide all these documents in comma separated manner. And then you can also provide the metadata about these documents as in dictionaries. So, and also you can provide IDs. So these three things you can simply provide in order to add documents to your collections. So basically here I am adding two documents. This is document 1 and this is document 2. So these are the metadata dictionaries for each of these documents. It's in order because this metadata will map with this document and also with this ID. Likewise, it's in the order. So this is the direct way you can add. In order to do this, you need to have these documents already extracted. The other way is to load the files, basically the PDFs, PowerPoint, Word document, any kind of file. You can use LangChain document loaders to load these files, and then simply extract the content from it, and then simply pass it to the collections. So here I'm using this particular function in order to get that done. So if I quickly go through, as I shown you before, in this data folder, I have these two PDF files. These are ChatGPT generated files about Australia and Canada. So here I am using the LangChain directory loader, and then I'm providing the directory path. So this is where I'm keeping all my files. And I'm using the PyPDF loader because I have all the PDFs. So if you have different types of files, just change the loader as here. And then you can simply load it. And I'm using this function given the collection and set of documents from the LangChain direct document loader. It will simply go through each of these documents and extract the document content, which is passed by the PyPDF. And then it will also extract the metadata, and also it will create a document ID, and then it will simply push these extracted data to this collection.add function call. This is particularly same as this one, but we are using LangChain document parser in order to get the content from the document. So this is how you can load the documents from the disk and push it to Chroma DB instance. In this way, you can directly provide data to your collection. Okay, so after running these two commands, I am adding some direct documents to the collection 1, and also I am adding some of the documents that I had in my Google Drive to my collection 2. So these two document sets are separated from each other because I have these documents in separate collections in my Chroma DB. So especially when I'm querying them, I can redirect them to the particular destinations. All right, so that's how we can add documents to our collections. Okay, so next let's talk about how can we view the documents in a collection. So given collection, we can get all the documents, and let's discuss how can beautifully visualize it. So in Chroma, if you run .get command, it will simply extract the documents and show you these documents. So for example, this is collection 1. We added these documents to the collection 1. So in the collection 1, we have these IDs and the documents and the metadata, all this information. So in the collection 2 also we have similar set of documents, but here we have a little bit of bigger documents, these PDFs. What we are doing here is we are using Python pandas to beautifully visualize these documents. So basically I am running the same collection.get command and I'm extracting these columns. I am interested about the IDs, the documents, and the metadata. So the document itself is the basically the body of the document. So if I run this, okay, I'm running this for the collection 1. So in the collection 1, we added these documents. This is document 1, this is document 2, and then these metadata and these IDs. In this one, we added some PDFs. So PyPDF will internally chunk them and decide the metadata, and also it will convert into the embedding. So let's see what we have in these two collections now. So this is my collection 1. I have these IDs, doc1, doc2, and then this is the content of these documents, and these are the metadata information, which is not correct. So if we visualize the collection 2, okay, it's something like this. If I go to the table view from here, I can see how it has been chunked, and I have the ID, and these are the metadata from 5 So I have, with this, I have actually four documents. Yes, 4 documents. And I think my PDF Australia has split into 3 documents, and the PDF Canada only comes as a 1 document. All right, so that's how we can visualize what we have inside our Chroma DB collections. All right, so I will hide this output. Okay. Okay, next let's discuss how can we update these existing documents in our collection. So I will consider this my first collection, which I have simpler documents, doc1, doc2, and this is document 1, and this is document 2. So in order to update a given document, we can do it by this simple approach. We can run the collection name, the collection1.update. Then we can give the ID. So I'm going to update this document in this example. So I will provide the metadata and okay. So what I'm going to do is I am going to pick up this document with the document ID 1, and then I'm going to set its metadata to this one and the document content into this one, so that it will update this particular document with ID. So when you're updating a document, always we need to provide the ID. So it will pick that particular document and update the metadata and the document content. So I will run this. So now if we run this display command, as you can see here, now we have, this is document A, and the source is also changed to ABC. So in that way, we can update the existing documents in our um, Chroma DB collections. Okay, so similarly, we can also delete the documents in our collection. Similarly, we can call the same way, the collection one.delete. So for instance, if I'm deleting this particular document, again, I need to provide all the documents that I need to delete as a list. So for instance, if I'm deleting the doc1, I can simply call this delete function. And then if I'm showing my collection again, the doc1 will be gone. So in that way, we can simply delete the documents in our document collection. Okay, next let's talk about how can we query our VectorDB. So now we discuss how we can create a VectorDB, create collection, and what are the different operations that we can do with these collections, and how can we add the documents to these collections, and also how to view these documents, update them, and delete them. Now let's talk about how can we query a VectorDB. So two things. The first one is the similarity search. And then we will also talk about retrieval augmented generation. So when it comes to similarity search, the simplest way we can do is, given a collection reference, we can simply call collection.query. Then we can provide the query text, and then we can provide the number of results. So this one basically do the semantic search or the similarity search using the embeddings, and it will try to find all the documents which is similar to this given query document. It will sort it out and provide the top two results. All right, so let's run this and see what happens. So this is what I'm getting. So I'm using the collection 2. As I said before, I have two documents, one with about Australia and the other one about Canada. As you can see, I'm getting the top two results here. Okay, so as I showed you before, the Australia PDFs got split into 3 documents, and the Canada one with 1 document. So from this, I'm getting doc 2 and doc 4. Okay, so this is document is about Australia. So the largest continent is matching with this as well as this. So it shows the metadata. So both from the chunks from the Australia PDF. So likewise, we can do the similarity search, and also the same thing we can do it in a little bit complex manner. So we can apply the filter so that it will reduce the scope and then do the similarity search. So this is similar to hybrid searching mechanism with the metadata filtering. So for example, here what I'm doing is I'm using the same collection 2.query, and the query text here is Australia. Then I'm looking for 10 top 10 results. And here I'm providing this where clause. So with the where, I am defining the source should be equals to my Australia.pdf. So here what I'm doing is I'm going to get the 10 most similar chunks or the documents for this given query, but I'm telling, okay, the source should only be this particular document. So this is narrowed down similarity search, which can be meaningful in many occasions. So let's run this, and I'm asking for 10, but I definitely know there are not 10 documents. There's only 3 documents with this source, so it should provide me all these 3 documents. So as you can see, doc 2, 3, and 4 are the documents corresponding to this Australia.pdf, this source. So it provides me all these 3 documents. Even though I asked for 10, it does not have 10. So it just limited to this source. It does not provide me anything of that Canada.pdf document. So, and also you can add more where clauses. So here it gives the documents which contain this term Australia. So these are different other filters that you can apply. So in this way, we can narrow down our searching scope and get more quality results. Another example with little bit complex one. So here I'm again getting the query text for the Australia, and here I'm providing two where clauses. So I can use this and keyword and then give as dictionaries these two conditions. The first one I'm also using this in command. So this says when you are doing the similarity search, make sure from the metadata the page label should be in 1 or 2 and the source should be from this australia.pdf. So I'm getting all the relevant chunks which is similar to this query term Australia, and it need to be from my first and second pages of this australia.pdf. So let's run that as well. Okay, so as I requested, it gives documents from the australia.pdf, and also it's just sticking with the first and second pages. All good. So that's how you can query the created collections in Chroma DB. Okay, so the final part is to do retrieval augmented generation, obviously with the vector DBs. That's all we are after. So in order to do the RAG, you can use LangChain. So here you can set the OpenAI API key and create the LangChain Chroma DB instance using our persistent directory. So far we use we use the Chroma DB library. So in order to build the RAG implementation, we need to use the LangChain. So what I'm doing is I'm creating the LangChain Chroma instance and I'm providing the collection name. So here I'm giving my collection 2, and persistent directory is simply I have stored all my data in my Google Drive. So we go to the vector store, Google Drive. All right, so finally, let's talk about how we can do RAG with the Chroma DB. So all we are after retrieval augmented generation with the vector databases. So so far we have used the Chroma DB directly through their library. So in order to build the RAG pipeline, we need to use the LangChain. So here what I'm doing is I'm providing the OpenAI API key because we also use LangChain for the language generation task. So here we are setting our OpenAI API key as an environment variable so that LangChain can use it. So then what we are doing is we are simply building the chroma using the LangChain. So it's very simple. We have already set this as a persistent client where all our vector DB will be saved in our Google Drive. So simply we can provide the collection. When we are querying, always we need to specify which collection is that. So I'm giving this collection name here, and then I'm also providing the persistent directory. where it can load all these vector values. And also I'm providing my embedding function, so which is the OpenAI embeddings. That's how you can specify your Chroma DB in the LangChain. So I will run this. All right, so next I am building this rack chain. So I'm importing the rack prompt from the LangChain hub. So this is how they are storing all the predefined prompts now in the LangChain hub. And then also we can call this Chroma DB instance that we created as a retrieval. Next, we can define this rack chain. So the context is coming from the retriever, and then we can ask question from the runnable passing through. And the prompt OpenAI is the LLM, and I'm also using the Spring output parser. So I can simply invoke this rack chain by providing it a question. So here I'm asking, explain me about the Australia. So if I run this, I can get answers from my VectorDB. All right, so I'm getting this answer. Australia is a country, continent located in the southern hemisphere, blah, blah, blah. All right, so that's all I wanted to cover from this tutorial. And here we talked about how can we do various operations with the Chroma DB. We talked about how can we install libraries and then import the required libraries. Then creating the Chroma DB client, there is two ways, the persistence as well as in memory. And then how can we create collections, defining the embedding functions, how can we update, modify these collections, and then how can we add documents to the collections directly through the text-based method and also using the document parsers. Next, how can we view the documents in collections, update the documents, delete documents, and finally, querying the VectorDB through the similarity search as well as retrieval augmented generation. All right, so that's all I'm going to cover from this tutorial, and thank you for watching, and see you again in another tutorial.